Okay. Unfortunately, the speaker who was actually going to give the talk that is on the schedule got ill and had to cancel last minute. Luckily, we actually had Paul, which is working with the Replicant project, had submitted some similar talk. So since it was so short notice, it was hard to prepare for a talk. So we actually decided to do a roundtable. I also have Karsten Munk from Yola with me. And the idea is, since both of them represent slightly different ends of the spectrum in the approach to problems and issues created by binary blobs and the issues we all suffer from it because of them. The idea is to have a sort of a round table, getting feedback from you guys also, thinking about ideas, thinking how maybe we can improve things by pressuring manufacturers more to actually release their source code, or at least help us to get their devices running without having to get through extensive licensing, expensive recompiles, or just making their hardware more accessible to people. I'll first let Paul explain his views, and he had a few projects in mind that are helping with it, and then we'll move on to Karsten, and then we'll take comments, discussions, ideas, and we'll see how this goes.
Right, thanks a lot. So what I've been doing now for the past 4 years at Replicant is mostly replacing non-free blobs, which are usually libraries and programs that are in a way drivers, because they relate to the hardware directly, and they are needed to actually get the hardware features to work. So those pieces of software, they're usually non-free on many different platforms and devices. And what I've been doing at Replicant is to understand how these work and try to write free software replacements for those. In the meantime, I also got involved with the Free Software Foundation to evaluate various embedded devices. So I would categorize a few different types of those. So you have mobile and non-mobile devices. So I've been working on mobile devices with Replicant, and so with that FSF project, we've been looking at non-mobile devices such as single board computers. So the most famous one of those would be the Raspberry Pi, but there are actually really a crazy amount of other boards that are single board computers as well, and that are more or less interesting for software freedom. So I've been looking at those and trying to find out exactly how they perform with free software. What can we do in the free world, and what is not yet working, or what do we need to write free software support for? So this has been very interesting, because from that very global view of the situation, I was able really to see a few major problems that we have today regarding freedom on embedded devices. So there are bottlenecks, which are areas where free software is just not there yet, especially on graphics acceleration drivers and GPUs. On embedded devices, the situation, or at least a few years back, it was a real problem. Now, thankfully, we have a few initiatives like FreeDreno and Lima and a few others that are trying to come up with free drivers for graphics acceleration. But for a long time, and for many platforms, especially the most popular one, which is the Power VR from Imagination Tech, for that we don't have any free software support, and that's a real problem. So that's the kind of bottleneck that we have that makes it very hard to use those embedded devices with free software in the free world. And another very important issue that we're facing today is the fact that early in the boot chain, you have bootloaders, which are that's basically software that's executed before the operating system starts, before the Linux kernel starts. And those bootloaders, on many platforms, they're non-free, and that's a problem, obviously. But we would think, yeah, we could still understand how it works and replace them. But the problem is that for various reasons, especially to be able to run DRMs, manufacturers have been enforcing signature checks on those bootloaders. It means that the piece of software that is installed on the device has a numeric signature, which is just the usual signature that you do with GPG. I mean, it's the very same thing, the hardware will actually check the signature, and it will refuse to boot if the bootloader is not signed with the manufacturer's key, the private key. And obviously the private key is private, so we don't have any access to it. So even if we were to write a free software bootloader, we could not install it on the device, and that's a very big issue for software freedom. So I'm talking about software freedom here in a very general meaning, in the way that Richard Stallman talked about the 4 basic freedom of free software that I think we all know about. Really, the idea here, at least regarding my work, is to take that ideal that, I mean, it's an idea, but to try to push it as far as possible, try to have free software, everywhere that we can. So that's why I'm interested in those things, and obviously there are many underlying reasons, especially if you're interested in security and privacy. You definitely want to have free software running, because with non-free software you can't really trust what's going on. So this is why we've been doing all this, and yeah, there is really a lot of work to do there, and yeah. So if you want to join in and maybe give another view of the situation.
Yeah. So I'm a bit from a different point of the spectrum, where we have been taking mostly open source based technology and trying to ship a device with it, which is the next challenge from when you actually have a nice open source stack. So the real challenge really becomes is, yes, those bootloaders are typically closed, but you have to remember a modern mobile device in terms of the software that you're getting on it. Okay, so let's say an Android phone. It's typical Android open source delivery. Then it is the chipset manufacturer's modifications to this. And then it's the ODM, as in the device maker's modifications to it. And between all that, it becomes a huge licensing mess, which is what we see from the outside. So our approach has been a little bit that, yes, we have blobs. We would like to ship because we would like to continue to do good open source. But at the same time, if you have to convince device makers to license things in different ways, you have to have good relationship with them, which means volume, and it means basically that you are shipping a lot of devices. So this is another angle on the topic. But the question is where does the limit go? Of course, that everything that can be open source should be open source. I like that thought. But at the same time, everything that comes with mobile is very cutting edge. A device that has hardware from 2 years ago is no longer remotely as sellable as one that was made just now with existing hardwares. So what we did was that we have this libhybris thing where we are using the existing blobs from Android. This is horrible and it's a hack, but it works and it gets us to a shipping device where it then allows us to have more open source on top of that. But the thing is that even if you go to China, for example, and you want to get a device made, and you go to an ODM, they often don't even understand the licensing conditions that the code they have is under. So it also becomes a matter of education and making people understand how this ecosystem works. And even on, we are making an Intel tablet at the moment, and even on a device where you would anticipate that you would be able to use typical open source drivers, like for example Mesa, you're usually buying these things in packages, as in that it comes with support, so it comes with commercial support. If you have a problem with the GPU driver or GPU, you go in and you log a support request. If you're running with an open source stack, it doesn't necessarily mean that you can get any kind of response on that. So in that vein, we've gone with what we know works with this particular kit, because Mesa covers the generic case, but for every single device there might be tiny, tiny modifications around that make the device actually work. So I think that we maybe just should ask the room, what kind of difficulties do you see in making devices today that are sufficiently open source and free, especially with technologies like EFI and Secure Boot, which can be both good and bad at the same time for free software?
I just got told about Minoboard being fairly open to deep down bits, and even graphics can be used in there. So that would be a good instance.
Yeah, as far as I know, there are two versions of the Minoboard. There is an early one and what they call the Minoboard Max, I think, the new version. And the new one does have Intel graphics instead of PowerVR. That was on the old one, I think. And they also allow to run a free BIOS, which is Core Boot. There is an effort to port it, so that's kind of nice. Yeah, that's a good example of yeah, it shows that we can actually do something right and good. And another good example, especially regarding secure boots and how I've talked a bit about signature checks, which are a real problem. If we look at the Chromebooks from Google, they have a very interesting security approach, which is that instead of necessarily checking the signature of the first bootloader to ensure that it wasn't modified, they put it in a read-only memory, and that can guarantee that it's not being modified, so that it's safe and it's there is no rootkit or anything. Well, I mean, if we trust that Google didn't put any rootkit in it in the first place, but what's really good about it is that the users can actually change it, but they need physical access to the device. Usually they are required to open the case and just remove a screw. And that's the physical contact that sets the chip read-only. And if you remove that, you can actually reflash the chip, which is no longer read-only. And that's a very interesting approach, because for most customers it's going to bring sufficient security, and for other people, it's just one screw away to be able to free your device. So I think that's a pretty interesting approach.
So the hardware switch for something like Secure Boot is always interesting, but then you come down to something like security and privacy. I travel a lot to China, and I travel to US at times, and it might be that my device is swept away during customs, and I might have some private data on my device, and it might be that by just having a hardware switch that can be switched, then suddenly the protection that I thought I had with all my own signing keys is suddenly gone. So that's the kind of evil maid trick as well, so you have to watch out for as well. I like to go to bars, and as you know, phones get lost in bars sometimes. I don't want my company data or even my personal data, my pictures, to be stolen. So it's really about finding a good balance, and we actually have this challenge with our tablet at the moment. We want to have a device that's focused on privacy, security, everything like that, but at the same time we need to find some balance between that and openness in actually being able to hack, for example, all operating systems on it.
You were saying earlier about secure boot and devices that boot only signed boot images. For Sony phones, we are providing a way to unlock your bootloader and boot any unsigned software. Only by providing us your email address, you will receive address and EMI. You will receive the code to unlock your phone. Second, the AOSP program, it's now providing an open source, almost completely open source environment for those phones. You have binaries only for the modem and for display, which is Adreno. Everything else, it's open source, and the code it's that we use, it's Google without any patches. So that can be done for every phone, starting with the ones manufacturers manufactured from 2014. And all the new ones, everything that will come out will have this feature.
Just a quick follow-up. Of course, it's great to be able to unlock the bootloader to run whatever kernel you want and whatever system you want. I mean, for people like CyanogenMod, which is a community Android version, it's really necessary for them. Else, it can't work. But really, what I was talking about was at a much earlier stage. Like I was talking about replacing the bootloader itself. So having it, you know, not being checked against, because that's on many platforms, especially on Sony, which is using a lot of Qualcomm platforms. Those only exist in versions that do check the signatures, and there are other chips out there. I'm thinking of the OMAP ones that exist in versions that do not have those checks. So on those you can have free bootloaders, and apparently on the Mino board, the second one, it's possible as well. And I know that, for instance, the Freescale IMX chips, as far as I know, there is no version that checks the signatures. So it's sorry?
All the Qualcomm platforms are checking the version, from my knowledge.
Yes, that's what I know as well. All the Qualcomm platforms are. Yeah. No, I know, but then it's the whole question is about selecting good platforms, and I mean. In Android devices, so many are using Qualcomm platforms. It's like it's a vast majority, really. And those platforms are, I mean, from our point of view, from the FSF's point of view, this is a fatal flaw. Like, we're not going to do anything good with that, because if we can't have a free bootloader, we can't do anything. It's worthless, really.
So I suppose one of the questions I would have about the sequence of software that's booting through to a device and the freedom associated with it is that what's the goal of freeing up the software? Is the goal to free up the software as a goal in its own right? You hinted about privacy and security, and the fact that the bootloader being provided for you is a mechanism by which you cannot be sure of the privacy and security. However, before the bootloader boots, the hardware is booted by, if I'm not mistaken, the modem. And kind of the point being that ultimately down the hardware chain, there are going to be areas where you physically are going to be running burned-in commands. And these are going to be provided, and they're going to be at the level of sophistication that you cannot realistically verify them without incredibly sophisticated analysis techniques that are realistically beyond our capabilities. So I'm just kind of interested in what the objective of some of these things are, and if you're looking at privacy and security, where do you accept the control of the manufacturers, essentially?
Yeah, well, there are, you know, with privacy and security, there are, you know, many different things to really to understand. So, first of all, the position of my personal position and the position of the Free Software Foundation is that you cannot achieve privacy and security without free software. Even if your bootloader is signed, and even if for the manufacturer it means that it's safe, for us it doesn't mean at all that it's safe. It means that it perhaps has a backdoor that you cannot replace. That's how we see it. So I mean, that's just not good for security, for us, from our point of view. Then there is also, you talked a bit about the modem on some platforms, especially on Qualcomm platforms. Again, we don't have all the documentation about that, but we have strong reasons to believe that on Qualcomm, the modem is basically in charge of everything. It basically controls the CPU on which Android is running. So this is why we think Qualcomm is even worse, because there is no way that you're going to get out of the grip of the modem. It's going to be there, and since it's running non-free software anyway, because it's so hard to replace, and it's signed as well. So even if we wanted to, it would be the same problem. So those platforms, we call them fatally flawed, and we just don't work on them. But other phones are made in different ways. There are many examples of, first of all, chips that don't have modems inside. This way, you know that the modem doesn't have control over the CPU because there is no modem. When you buy a Wi-Fi only tablet, there is no modem around. So that's one problem less to care about. And on devices where you have a modem that is separate from the CPU, we try to find out how it's connected between, how one is connected between the other to figure out, well, can the modem access the RAM? Can it modify it? Can it access storage? Can it modify it? So that's really what we're trying to find out, and it's hard because obviously we can't know for sure because we don't have schematics. First of all, even if we had them, and in some cases we do, because sometimes they leak. So we just see those. But then what? How can we know for sure that they didn't decide even on their internal documentation to hide stuff? We can't. Are we going to trace the PCB, the printed circuit board? It's insane. They are like often different layers. It would require an incredible technical work. So it's just too hard. So what we do is that when we have proof that that the link between the modem and the CPU implies that the modem has a lot of control over the rest of the device, we just say we know it's bad. But when we didn't find such proof, we cannot say it's good. We can only say maybe it's good. We don't know for sure that it's bad. But so that's not a very good situation for privacy and security. That's why, really, at Replicant, we have a page that is called recommendation, and there is a red box that says if you're doing something that is really serious, like if you're a journalist working on some sensitive areas, you should not use the phone at all because you can't trust that the modem is not going to access your data. Just as simple as that. So, yeah.
But I think the challenge is also, I'll get to you afterwards. So the challenge is also that we're moving to more advanced technologies. Let's say, I think it's NVIDIA. They have LTE modem, which is software-based radio, which it becomes incredibly more interesting from a privacy point of view because you can't really know what it's sending at what point, because deep down you can't trust any components unless you have handmade them yourself, and that's not happening today. So it becomes a question of, okay, so how much price difference in practice, price difference between a fairly privacy-aware phone versus one that a typical customer would buy, and the pricing difference. So I think that if you're looking at what's happening in China with new SoC makers like MediaTek, Spectrum, etc., they have a completely different codex towards open source or anything in the first place, and that means that it's going to be even harder because these phones are going to be cheap. This is what's going to be in people's supermarkets that they can go and buy. So to say the least, we are all screwed.
Yeah, I have a question about privacy and security on smartphone. So I was wondering because I don't know how to switch off my tracking and disable, because I know it's not disabled by default on old smartphone. And I want to know if you have any advice to stop the location, of tracking, because I know that even if your phone is shut down, it is still tracking you. So it depends on the model, but I became paranoid with that. So I just want to ask this question first. I have other question, but I don't know if you have already an answer to this one.
So this answer is probably going to scare you. If you really want to disable tracking in a mobile device, you should not be using the mobile device at all. If we're looking, for example, at the US, there's a set of legal requirements for mobile phones, which is called E911, which is in the case that you go into some kind of a situation where you have to call 911, it has to be able to locate you, and if it has a GPS, which in many cases is located inside the modem, then it has to give up whatever location you have or nearby cell towers and send this along with the telephone network. So while there's very nice settings towards disabling tracking on mobile devices, in some situations they don't actually work. But for typical things like, for example, you don't want to let an application have access to your location, it might be that it doesn't allow you access to your location, but it might also be that your application then looks instead of the Wi-Fi networks around you, and then it can find your location pretty well anyway. So it becomes really hard to not being tracked.
Yeah. Oh, well. Yeah, there are some ideas like that. Richard Stallman also proposed to use a directional antenna to only direct it at one tower so that it could not triangulate you, but that's an idea. Perhaps it works. Maybe a Faraday cage would also provide reliable isolation. I like the idea that by removing the battery, everything is off. It should be that way. Maybe we'll find out in the near future that it's not the case. I don't know. We didn't read all the leaks from Edward Snowden, so perhaps there is something about it there. We don't know. But in any case, it's true that, yes, modems are required to send their location just when they're asked to. It's worrying, it sure is. On Replicant, we're also trying to provide we're not doing it yet, that's one of the things I want to do, but to provide documentation about how to reliably power off the modem, because when you have a device where the electrical control of the modem is something that we have power over, if it's just a chip that we can instruct to cut off the electrical line, that would be a reliable way to make sure that the modem is off and that there is no further tracking going on. But then again, that's only possible if the modem is clearly separate from the CPU, which, for instance, in Qualcomm platforms is not the case at all. So on some platforms, that could be possible, and we could, I guess, reliably test whether that's the case or not. So there is some work to do.
Well, the question is also that despite the fact that your modem might be powered off or electrically cut off, it doesn't mean that you can, for example, have a small wireless chipset, wireless charging chipset inside the modem, so it powers on by its own from some kind of wireless charging. But the question also becomes, who's our enemy in practice? So if we have to design our phones so NSA can't deal with it, that's a little harder. But at the same time, there's an immense amount of data being collected by bigger companies. And I've been reading a book recently, which is called The Internet is Not the Answer, that I really can recommend people to read, because it really shows the kind of approach towards that kind of a little like the first industrial age, where there's a lot of big barons that own the land and everything. And if you're noticing how the internet actually works today, everybody's collecting data about you. So maybe that's the first step, that you should prevent people or bigger companies from collecting too much data about you. Because it turns out that us humans are surprisingly predictable if you have a little bit of data on you.
Yep.
I'll take it there. Maybe you can use the microphone down.
Hi. My name is Cvetan Uzunov. I'm from Olymix, and we are making open source hardware boards. And now we are talking about free software and the benefits, everything to be open source and to maybe looked at, edited, and etc. But I would like to share our experience with the Chinese manufacturers, because there was such talk at the beginning that the Chinese manufacturer hide the specs, they don't give the documentation, and said, we work with one Chinese company since 2012, and we also struggle the same. At the beginning, it was very hard to understand how this company works without documentation, release chips, but nobody cares to support them and things. And what we learn is that this is highly competitive market. You have window of 6 to 8 months to sell your product. They always work with the cutting edge technology. If something new enters to the market, they start immediately work on this. And they found a way to release the products quickly. How? No documentation. They make reference design for the factories. So the factories, they don't do any R&D development. They just get the design, and next day they start producing tablets, phones. If you open all these Chinese low-cost phones or tablets, basically they are with the same hardware reference design inside, just different batteries, LCDs, layout. So this is impossible for the Western company. Western company, what they do, they make the processor, then write 6,000 pages, user manuals, documentation, throw it to the developer, they start reading this, and after 1 year, they design something with this processor. This is impossible in China. When if you lose 1 year, you don't sell anything, because your Windows is 6 months to launch your product and to take the profit, to break even. Otherwise, you're just selling on loss. And we understood that they don't hate open source, or they do this violation intentionally. No. Most of these binary blobs you see, they buy from other companies. They even don't know what is inside. So we had problem for the video encoder, for instance, and I'm describing my problems to the engineer, and he sends me fix, which is with name CedRX crack. So they're buying this from other company, and they made reverse engineering to crack the engine so they work without paying royalties. This is how it works in China. And this is not because they don't want to release the source, they don't have it. And I think we will be always in position to catch up after them. But the problem is that by the time you make the open source drivers and open everything, this product will be obsolete and nobody will be using it. So what is the positive experience? When we started with this Chinese company, they didn't care about support and everything because we have been very, very small customer. But we are making open source designs, which people can use to modify and make their own designs. And all winners start seeing that the interest to these chips, which we are using in our designs, continue after these 6 months. For instance, 2 years later, nobody is using tablet with their A10 processor. But people put this A10 processor in many different projects, and they keep selling. So they learned that open source brings them more money and extend the life of their product. And this is, I just feel how they turn their attitude. They start to respect open source, because for them this is more money. And I think we should educate all these GPL violators and things that respecting open source will bring them more money, more business, and then they will do everything properly. And we will not be into position to reverse engineer binary blobs and to do this. Even there was announcement, Allwinner become Linaro member, and they made announcement that they for their newest chipset, A80, they are releasing kernel 3.10 with device tree and everything inside properly. So this is, we have somehow to educate them and to show them that this will bring to them more business and more money. This is the only way you can convince Chinese manufacturer to respect open source and to do it properly.
So first of all, I really want to say thanks a lot for what you're doing at Olimex. It's really great. And am I correct in assuming that the Chinese manufacturer you're talking about is Allwinner? Yeah, all right. So it's really interesting to see how those Asian chip manufacturers react to free software. And there is actually a very interesting blog post from Andrew Huang, who is better known as Bunny. And he wrote an article called, I think, From Guankai to Open Source, where he describes how it's going on for those chip manufacturers, especially with the example of a very cheap phone. And it's something incredibly interesting to read because it shows the cultural difference there is between those Asian manufacturers that, like you said, they're cutting edge and they really want to get it done as fast as possible. So that's why when we get source code, and we don't always get source code, but when we do, you can see that the code is written like as fast as possible, and it's very unclean and all that stuff. And obviously they don't provide support or anything. So I really hope that we can somewhat pressure these companies to do better. And if that's what you're trying to do, thanks a lot, because that's really what the work that is needed for these companies. And that's very important work to do. And obviously making them understand that yes, we have interest in their platforms, and if they decided to go our way, a little bit more, it would be beneficial for both parties, really. So yeah.
So maybe one question about one thing about the bad code is that the average consumer practically they don't give a shit if it's well architectured code, to say the least. If you get a working product out, it's working mostly a little buggy and so on. Okay, that's the quality thing of it. But at the same time, I think we here in the West we are doing the mistake that. I don't know if in kindergarten you were ever asked to go into a chicken farm or seeing how an animal is slaughtered to make food. And I think we should really take the lesson to also try to make these devices and actually see how it's made. Go to the factories, get the experience. We've been lucky because we have people in Yola that has actually made devices before, when they were working in Nokia, for example. But you really to understand how to approach these companies, you have to understand how it's made, how their culture is working, get relationships, and maybe spend a couple of months in Taiwan or Shenzhen or wherever.
I'd just like to come back to some of the other stuff that was coming out before. Personally, I feel that from a kind of a freedom and software perspective, it's probably better to offer as free a solution as possible to as many people as possible, rather than a totally free solution to almost no people. So I'd just like to kind of suggest that that's personally how I would approach the problem, because I think that provides a level of data privacy, a level of awareness of free software. So when I've been kind of approaching this problem and I've been thinking about it, that's been the approach I've been taking. So just throw that out for comment and maybe response.
One of the kind of things that did start happening in China is something a little different. It's basically that, for example, some of the vendors are talking about social responsibility, how fair the materials are, that kind of stuff. if it can happen on the hardware level, it should be possible to happen on the software level as well. But it takes a movement, it takes strong support, it takes people that refuse to buy things because they are using, let's say, slave labor or whatever.
Well, yeah, sure, fair enough. That would be, yeah, that would be possible. Yeah. Yeah. So, oh, we have one last question. Just quickly, yeah, I forgot to get back at your point of having more users and a little less software freedom versus the opposites. It's what Firefox OS have been doing. I mean, their plan, when you talk with Firefox OS developers, they say, we want to have as many people as possible using our device so that we can bring change and bring freedom and, you know, have leverage power, be able to, with a good amount of users, be able to change things. And so that's one way to achieve software freedom, which is not the direct make it fully free way. And I mean, it's always an interesting discussion to have. What is going to work best? Is it better to compromise at first, get a lot of users, and then improve the situation because you're in a position where you do have leverage because you have a lot of users? That's something that can work on the long term. But obviously for the Free Software Foundation, it's not acceptable to say that we agree that your freedom is denied and that it's not something they can do. But I do understand the argument that maybe in the long term it's better to go gradually, and yeah, it makes sense. I wouldn't say I fully agree to it, but it does make sense, yeah.
That's a question.
I joined Linaro a few months ago, and I deal with Chinese manufacturers on weekly basis, let's say. And, you know, for some people from some places talking about freedom is like if you go, I don't know, to the US and you tell them how cool it is to have all the, I don't know, buffaloes walking around wherever they want to, right? It's a world they don't understand. They don't live there. So you have to, we try to bring them into free software world based on pure concepts like time to market, associate to support life cycle of devices, or you know, we try to find all kind of arguments that they can understand, and they do understand business very well. They are very good at that, right? Beyond the cultural difference, but approaching them from the freedom point of view is completely nonsense. And when they get beaten all over the social media by these kind of arguments, it's very hard to understand for them. And because they work very hard to get the best possible products out there at the lowest price, they sell them, they get crazily successful at it, and here we are, a whole bunch of people telling them that they're not doing the right things, right? In a context that it's simply it's completely useless. I mean, our job is somehow to try, I mean, as a side effect, to try to bring them into this side of the story. But I'm not saying that we should not beat them with these arguments. Come on, I'm not saying that, of course. I'm just saying that it's not the kind of arguments they will be listening to. They will be listening to other arguments that are, from many other points of view, as powerful as those ones, make sense from many other points of view, and they are some of the companies we are working with are making huge progress in time frames in which Western companies have failed miserably, just because they have a very powerful and strong business point of view, and they are absolutely crazily efficient in what they are doing. So when you talk to them about efficiency, It's when they really start to talk about, when you talk about cost reduction in 3-year period. It's true that they just think about the next year, but some of those companies have been around enough to understand that they need to also start thinking midterm. Those arguments work very, very well. Surveillance, privacy, those are completely Western world-related concepts. Talking to them with these arguments, in our experience, works poorly.
I guess we can start wrapping up. Like, anything last thing to say?
Well, I won't say I disagree with you. It's just that in our position, in the Free Software Foundation's position, we're talking about software freedom because that's what we're interested in. I'm not saying that we should go and talk to those chip manufacturers and try to convince them that freedom is important somewhat. I know they're not going to be sensible to that, and we're not even seriously thinking about it. But still, that's why we're doing it. So, yeah, maybe there are other approaches to have that will lead to that conclusion. That is what we want. But yeah, then again, it's really it's a complex question of how to trick them into giving them what we want and for the reason that they will listen to. So that's something very interesting to discuss. Yeah.
So I'm sorry, I've managed to fill the hour actually, so I'm really happy about that. I think we had some quite interesting points of view. We got some more education for ourselves also about how we could maybe make decisions that would help us to improve this freedom. Thank you very much, and thank you Paul and Karsten and all of you that interacted with us.